So remember, this is just the area of the base times the height of the prism. All right, so your volume here is just the area of the base times the height of the prism. In this case, your base is a regular polygon. So that is 1/2 your apothem times your perimeter. And then the height, they actually gave it to you. That's 14. And they gave you everything you needed. So 1/2 apothem, they gave you the apothem. That's this number right here, 8 centimeters. All right. And then the perimeter, well, one side is 11.6. And you have how many sides here? 5. So your perimeter looks like that, 11.6 times your perimeter. So this whole thing represents your base. And you are going to multiply that by the height of the prism, which they also gave you, 14. So this piece is the height of the prism. So 3,248 is what you should have gotten there.
If they don't give you the apothem, you do it by Pythagorean theorem, right?
Yeah, it depends. So this is a pentagon. You'd probably have to use special right triangles for this. Well, actually. Yeah, because you don't have, you can't assume with a pentagon that it is, you have the hypotenuse. For a hexagon, 6-sided, you have a 60-60-60 triangle. So the hypotenuse of that triangle that you created is the same as the side length. That's not true for a pentagon. So I'm going to give you ones that you can either do special right triangles for or Pythagorean theorem. One or the other. But you can't use Pythagorean theorem for this one. So, any other questions on that one? All right, 26 was the other one. 26 was a word, not really a word problem, but a little bit kind of. Not like the one that you had for bell work, but similar to the word type of word problem I would give you. The question was, how many gallons of water will fill a 38-foot tall circular cylinder with a radius of 27 feet? And then it gives you the conversion there that you would need to be able to figure out the gallons of water. So you do need that conversion that they give you to be able to do this. The answer here was 650,972 gallons, by the way. All right, so let's look at this. The first thing you need to do is figure out the volume. All right, and they really give you everything you need for the volume. If you think about what they've given you and what you have, this is a cylinder. So we have a cylinder, circular cylinder, if it lets me draw this. Tank. All right, so we have this tank here. And they have given me really everything I need to do this part of it. All right, so they said 38 feet tall. So that's the height of my cylinder. Radius of 27 feet. And so I also have my radius here. All right. So the first thing I need to do is I need to figure out what the volume is in cubic feet. And that's just going to be the area of my base, which for a circle is pi r squared, times the height of the prism. Once again, base times height. So I'm going to fill that in. I'm going to say pi times my r squared times my height. You should have gotten something. I mean, if you round it to the nearest whole, which is I think what they were doing, you would have gotten cubic feet, about 87,000 cubic feet. Okay. They asked for gallons, and then they gave you the conversion factor. So if you look here, they said for every 1 cubic foot, it is 7.48 gallons. So what do you need to do with your cubic feet to get the gallons? Yeah, multiply. So you would have taken this number that you have in cubic, well, let's not write it in highlighter, in cubic feet. So you would have taken your 87,028 and you would have multiplied that by your conversion factor of 7.48. And you would have gotten 650,972 gallons of water. All right. Any questions on that? But as you can see, when you actually do it out, assuming that, you know, rice isn't filling all of the space, we know that. The volume of a pyramid is 1/3 the product of its height and the area of the base. You'll notice it looks exactly like your prism formula, except you are dividing by 3 or multiplying by 1/3. Same thing. So then we go back to the one that they had in the last section, the Memphis Pyramid. Find the volume of the 321 foot tall pyramid, which has a square base that sides measure 591 feet. So we basically have this pyramid, and it has a square base, right? And what they're telling us is that the sides of that base are 591. All right, and because this is a pyramid, and it's going to look more like this, right, with the pyramid. We have this pyramid, all right? 591 are the sides of the base, the height of the pyramid, and they're talking about the perpendicular distance when they say height of this pyramid, not the slant height. For lateral area, we used like if you sat at the top of the pyramid and slid down the sides of it, not that I would recommend that, but if you did, right, that is lateral height, and that's the slant height that we use with the lateral faces. This is actually perpendicular height if you took a string straight from the middle and went straight to the base inside. That is the perpendicular height that they're talking about here, and that is 321. All right, so if we were going to calculate this, we would say 1/3 the area of the base. That's what this B stands for. That is the area of the base. If you have your formula sheet, you should have a cone and a prism or a pyramid on there. 1/3 the area of the base. The area of a square. What do I do to find the area of the square? Just multiply the sides, right? So it's 591 basically squared times itself, right? That's the area of the base. The height of the pyramid is 321. And it's pretty big volume, actually. They have it out for us. Again, this is a cubic measurement. That's what it would take to fill it up, if we had to fill it up. Just like you filled it up with rice, the volume is telling you how much it takes to fill it up. Let's review the area of a rhombus when they give you the diagonals. How do I find the area of a rhombus given the diagonals? Yeah, just 1/2 diagonal 1 times diagonal 2. So to find the area of that base, that is a rhombus if you do not remember your rhombus formula. If you do not remember your rhombus formula. Theorem for a cone. Back to the page right before this, page 429. Cone is identical. It's just that the area of your cone is always going to be the area of a circle, which is pi r squared. And so the volume of a cone is same thing, 1/3 area of the base, pi r squared, times your height. 1/3 pi r squared times your height, all right? Oblique cone like that, or pyramid like that. So you got to make sure you know these area formulas for your bases. Regular polygon is apothem times perimeter divided by 2. And then just plug it in. Your base, this whole thing represents your base. Your height, they gave you your height. And don't forget your 1/3. Your 1/3 for these. So go ahead and try a couple of these. We have 2 oblique. This is a trapezoid, so don't forget your trapezoid formula. And then they just want to ask you which one has a greater volume. Basically, the rule is that if you have some oddly shaped figure, you can break it up into figures that you know and just add up all the volumes. All right? So you can take each one of these and do the volume individually. If I were to do this, I would do 2 times 2 times 4. So this volume here would be 2 times 2 times 4. All right? And so I'm going to get 16 cubic millimeters here. And then you can go to the next one. If I have this right here, 8 times 8. And then if I want to find this piece across here, I'm going to use the 2 and the 6. So I have for that one 8 times 8 times 8. That's actually a perfect cube there as well. So I'm going to get 512 cubic millimeters here. And then for this last one, I have 10, that's one of my dimensions, by 6. And then my height, well, I know that this is 3. I know the entire height is 8. So my height here is actually 5. So for this one, I'm going to get 10 times 6 times 5. So I'm going to get 300 cubic millimeters here. All right. And so when I add all of these up, the 512, the 16, and the 300, I'm going to get 828 cubic millimeters. And so when you have composite type figures, you just do them individually and add up your volumes. And that's what, I mean, that's just the theorem there, is that if you have a composite figure, just like with areas, you could do the individual areas and add them. You can do the individual volumes and add them.